Okay, so what is left to do in this chapter 21 is the last section, that is 21.3. Now, just to refresh your memory, last time, I mean, we're talking about, again, this is electrochemistry, and we are talking about two types of uh, electrochemical cells. The one which we discussed before was the voltaic cell, where we have a spontaneous reaction that is producing electric current as a result of the reaction. So basically, we're converting chemical energy into electrical energy. That is what we have in a voltaic cell, or sometimes they call it galvanic cell. Now, today we are talking about the second type, which is the electrolytic cell, in which we have a non-spontaneous reaction that is enforced in order to go, and that is by applying energy in a form of electrical energy. So the first thing that we need to do is to distinguish between the two voltaic cell, or compare between the two types, voltaic and electrolytic cell. Then in the application here, we're going to do the first part, which is the electrolysis only. Electrolysis of H2O, electrolysis of brine solution, and electrolysis of molten sodium chloride. But the second part of the application, which is electroplating, electrowinning, electro refining, and these kind of the for application which is related to electrolytic cell, we're not gonna cover that. Okay, so I'll show you where we stop, but for now we are going to see the difference between the two cells. Now, what is the meaning of electrolysis again? uh, what is this question, ya Abdullah al-Mtayri? Is this 10 a.m. class? What time is it now? والله شكله رمضان مثل عليك يا عبد الله المطيري. Yes, it is 10 o'clock class. You have a problem with that? Anyway, electrolysis is basically the process by which electrical energy is used to bring about chemical reaction. And this is an example of the application, the one that we are not going to discuss, which is the electroplating. This has been electroplated by silver. Some people, they use tools that are electroplated by gold, and that is by depositing a very small layer on the tools, and they will look, beautiful. And people, they do this for luxury purposes. There are some automobile parts that are chrome plated, and we have seen that before in when we talked about corrosion and how to prevent it by electroplating. Anyway, electrolytic cell again is an electrochemical cell that is used to cause a chemical change through application of electrical energy. All right, so electrochemical cells, again, electrolytic cell is an electrochemical cell that causes a chemical change by applying electrical energy. And it is used usually for non-spontaneous reaction. When we have a non-spontaneous reaction that is not possible to happen by itself, we enforce that by applying a direct current or electrical energy in the form of a direct current. Okay, here's a picture of both electrolytic and voltaic cell, and you can see the difference between the two. The first difference is having the salt bridge between the two compartments. Here, there's no need for salt bridge because the electrons are enforced to go through. In the case of the voltaic cell, we had the porous plate salt bridge, or the salt bridge that we have seen before, which is looks like that. That is for two purposes. First of all, not to mix the two electrolytes together, because these are two different electrolytes. Here we're talking about the same electrolyte. There's no need to have two solutions like the case of the voltaic cell. The second major difference is the energy. Here energy is produced, and we're talking about electrical energy specifically. So we are producing energy in the case of the voltaic cell, but here we are applying energy. We put energy on the compartment in order to produce a chemical reaction and produce a new product. Also, in both voltaic cell, that you can see that electrons are flowing through the wire from the anode into the cathode. But here, this is a natural flow, if you wish to call it natural, or spontaneous flow of electrons due to the oxidation of that one and the desire for that a plate or electrode to undergo oxidation, producing electrons. Those electrons will have the ability to go through the wire because there is a metal over here that is waiting for those electrons to undergo reduction. While in this case, it is the electrons are enforced by the battery to go through. And when they go through, also oxidation will happen at the anode and the reduction will happen at the cathode. So the major difference, the main key difference between the two is that the flow of electrons is here resulting from a spontaneous reaction. The flow of electron here is enforced by a battery. And that's why energy is produced in this case, energy is added in the case of electrolytic cell. Now, one other notice is the fact that the anode is always negative in the voltaic cell, and the cathode is where reduction occurs is positive. Here we can see that signs are changed in the case of electrolytic cell. So I hope by this you understand the difference between those, although I mentioned it several times, that voltaic cell is for spontaneous reaction that is going to produce electric current. So basically we are changing or converting a chemical energy into electrical energy. In the case of the electrolytic cell, we have electrical energy that is used for to enforce a chemical reaction. So basically we are performing a chemical change by using electrical energy. Now here's the question for you, which is the question says in electrolysis the current is used to do which of the following? Is it to cause a chemical change, to produce a battery, or to generate heat, or to run a motor? What do you guys think? بس هديل اللي بتعرف الجواب. Well, it seems that نصكم نايمين, which يعني to some extent I don't blame you, but that's fine. Yes, yeah, Lena, very good. It is the chemical change. I mean, we said that many times now, that in electrolytic cell, basically what we are doing is we are performing a chemical change by using the electric current. Okay. Now we're going to move to the non-spontaneous processes and how to derive that through the applications that I told you about. So what do we have in the case of electrolysis and in terms of electroplating? In terms of electrolysis, we're going to take examples, or we're going to explain the electrolysis of solutions. If we have a solution like that, and then we put two electrodes, connect that into a battery, a chemical reaction is going to happen over here, depending on the type of solution. So we're going to talk about electrolysis of H2O, for example, to produce O2 and H2, which is not possible in real life. It is not possible for the water to split into hydrogen and oxygen by itself. That's why we call this a non-spontaneous reaction. Okay, but with the help of the power or electrical energy, we can do that. In addition, we're going to talk about the melted sodium chloride or molten, in addition to having a solution. So when we have a solution of sodium chloride with a very high concentration, we call it brine solution, and that is can be used also for electrolysis. We can melt the sodium chloride or any other ionic compound and perform electrolysis as well. Now, the second part of the application, which is up here, is about electroplating, and that is not going to be covered. Okay, so let's go ahead and start with the electrolysis of water. If you have a beaker like this and you put inside here, you put pure water. Pure يعني no ions, nothing, no salts, no impurities, nothing. And you place the two electrode and connect it to the power, what will happen? Nothing. Nothing will happen. Why? Because these two electrodes are not, electrons cannot flow through the solution. Why? Because it's a pure water, it's non-conductive. It cannot conduct electricity. But if you add few drops of sulfuric acid, nitric acid, or any other electrolyte that will separate into ions, immediately you will start seeing bubbles. What is these bubbles are coming from and what's going on? What will happen is that the solution becoming conductive, and that will result in flowing the current from the battery that we connected to, and that is going to happen like that. So here's the battery, that is the source of power. These are the two wires with the two electrodes, and this is the bubbles that you're going to see collected in these upside down test tubes, and that is due to the collect, this is the way to collect gas. So you will notice that water will decompose into oxygen gas and hydrogen gas. Okay, so for example, hydrogen may go here and oxygen may go in, depending on which one is the cathode and which one is the anode, where oxidation happen and where reduction happen. So what is happening here with the electrolysis of water? What's happening is that water is oxidized. One water molecule is going to get oxidized into oxygen gas. And that is by going from -2 oxidation number into 0 oxidation number. So that is an increase in the oxidation number, and that's why it is oxidation. So one water molecule will get oxidized into O2, producing 4 electrons. Now these electrons are used in order to reduce another hydrogen or water molecule into hydrogen gas. So the main product in this case are these two, the oxygen gas and the hydrogen gas. These are the two main products. So if you add these two equations together, apparently you have to multiply the reduction equation by 2, and that is in order to make sure, as we agreed before, that to have a chemical or a cell equation, then you need to make sure that the number of electrons gained is equal to the number of electrons lost. طيب, when you add them, then these are going to form 4 H2Os, because we have 4H plus and 4OH minus. So that is 4H2O. This will become 2, and that can be cancelled. So we end up with a reaction like this. This is a non-spontaneous reaction that will never happen by itself unless you apply electricity by connecting the two electrodes in the depth in the solution with connected with electric power. That it could be a battery, could be a direct current, could be anything. Okay, so that is the electrolysis of water. All right. If the electrolyte in the aqueous solution is more easily oxidized or reduced than water, then the product of electrolysis will be substances other than hydrogen and oxygen. يعني احنا remember we said that we have pure water, then nothing has happened, right? Then we add H2SO4 or HNO3 drops only. We don't add this huge amount. We just add the drops in there. It says here that if you add more of that electrolyte, there will be other ions that will compete with water in the oxidation and reduction. One good example on that is the electrolysis of brine. Brine is basically, instead of adding sulfuric acid or nitric acid, they added to the pure water a lot of sodium chloride. When you add a lot of sodium chloride, the solution will be supersaturated with Cl minus and Na plus. So the question is now, is it the water is going to get oxidized? No, because a chloride ion is more easily oxidized than the water molecule. So we're gonna see the Cl minus is getting oxidized into Cl2, and that is the way we produce chlorine gas. Then we have the sodium and we have the water left in there. Now, which one of those is going to get reduced? Apparently, the water is more easily reduced than sodium. So water, again, is going to get reduced into hydrogen gas. And the sodium which is left in the solution will be combined with the hydroxide ion that is produced from the reduction of the water molecule. So this is the setup. Basically, we're gonna add a lot of sodium chloride into the solution, so make it a brine solution. Then we apply a power through the plates, and then you will notice that a lot of bubbles will start coming here. When they check that, they found this is chlorine gas and that is a hydrogen gas. So at the anode here where the oxidation occurs, this is the reaction that is happening. The 2Cl minuses is oxidized into Cl2 or chlorine gas. Then the water, on the other hand, is getting reduced by the 2 electrons into hydrogen gas. And what is left in solution is sodium ion along with the hydroxide ion. So that will produce sodium hydroxide at the end. Okay. Now, why the sodium is not being reduced? Because the water is more easily reduced than sodium ion. So if you want really to make sure that this is going to happen, you have to eliminate the water. I mean, water should not be there. Okay, so in the case of pure water, again, pure water, nothing will happen. Now, water with some H2SO4, for example, then that will produce O2 plus H2, which is electrolysis of water. Now, having water with lots of sodium chloride, that will produce Cl2, H2, and NaOH. If we eliminate the water, how are we going to eliminate the water? How are we going to make a solution without water? The only other choice is to melt the sodium chloride. Instead of making a solution, we're going to make a molten sodium chloride by dissolving it with heat. So if you do that, then you will be able to produce sodium instead of producing hydrogen in this case. These are the two half reactions. This is the way it's going to look like after adding everything. All right. طيب. Then the third type of electrolysis is the molten sodium chloride. Sodium and chlorine are produced through the electrolysis of pure molten sodium chloride. Now, for the Cl minus, there's no change from the brine. This will get, oxidized into Cl2. But here in the case of the brine, there was a competition between the water and the sodium ion. And we notice that the water is more easily reduced into H2, while this remains a solution. Now, we don't have the water, we only have the sodium. So sodium does not have any other choice except getting reduced into sodium metal and collected as sodium liquid. So these are the two reactions that are expected: the oxidation of chloride ion into chlorine gas and the reduction of sodium ion into sodium liquid or liquid sodium. Okay, So if you add them together, then this is the overall reaction. If you want to compare that with the overall reaction over here, that this is what we have. You see, because of the water there, we did not have a sodium solid, rather we have hydrogen and sodium hydroxide. While here in this case, because water does not present, we only have chloride, chlorine gas, and sodium liquid. This is the kind of device that is used for that purpose, and that is at the industrial level, which is called Downs cell. Of course, sodium chloride is like typical any other ionic compound, which is have a very high melting point. So you need to heat up the sodium chloride. In order to melt it, you need to go above 800 degrees, above 800 degrees in order to get into that liquid. Well, then you apply your electrodes and you will start seeing chlorine gas collected from the top as a gas, and the sodium liquid is collected from the side here as liquid sodium. Okay, so to summarize those again, as I said, I'm just going to take you back over here. Yeah, pure water, nothing is going to happen. Water with some electrolyte will produce O2 and H2, and that is electrolysis of water. Sodium chloride with H2O, that will make a brine solution. Electrolysis of brine solution will produce hydrogen gas, chlorine gas, and sodium hydroxide. If you eliminate the water and having molten sodium chloride, then the products that is resulting from the electrolysis is going to be chlorine gas and sodium liquid or liquid sodium. Okay, that is basically what I want to say about this chapter. We're gonna stop right here. This is the last section, and this is the last thing that we're doing with this course. Okay, so I will be, or I already uploaded the homework for this, the last homework for this chapter, and it will start, it will be open at 11 or at 12 today, and will remain open till Saturday. So starting next class, on Thursday, attendance is optional, and we will be doing review. So review means that I will answer your questions. If you don't like having the class at 9 and 10 for two sections, we can arrange for a class, review class in the evening, at 10 or 11 or what time you guys interested in. And again, the attendance will be optional. If you interested in something like that, rather than having the classes as scheduled, I have no problem as long as one of you will talk to the two groups, the section 3 and your section, and get me and send me an email, say that we agreed that we would like to have a review class on Thursday at 10 p.m., for example. I will issue a Zoom link and I will email it to you guys. But you have to send me a request for this. But has to be also by accepted by everyone, because this way we are canceling the classes and as scheduled, and we move to a new timing, which is in the evening. Okay. طيب, this is going to be the last class. Thank you very much for being with me for almost a year now. I mean, for 2 semesters for most of you. I would like you to forgive me if I, did anything unintentionally for any of you. And hopefully you got, inshallah, admitted into your College of Desire, and we will see you around Al Faisal, and you are not going to be my student, but I will be, inshallah, talking to you later. Okay. Thank you, and have a blessed Ramadan. Take care of yourself. Stay safe, and inshallah, the first day will pass easily. Okay? All right.
يلا السلام عليكم.